Totally. That's what I do in my off hours. Yep. Every day. Yep. I do. Totally. Every day. You caught me.
Bad idea.
Okay. Woo. I think that was mine. So, you guys, if you are tired of making plots and doing the medium mode and all that number crunching, we're switching gears a little bit. Chapter 4 was probably our hardest chapter. So we do chapter 11 after that because it's a little bit easier, a little break for your brain. But unfortunately, we end up forgetting how to graph equations of lines and things like that, which is no bueno. So we're going to get back into a little bit more solid algebra. So chapter 5 is about things called systems of equations. So we're going to start today. We're going to talk about what is a system of equations. I feel like this is something you talk about in middle school. The chapter covers how do we solve them. So we're going to talk about that. That's the first half of the chapter is how do we solve systems of equations. Second half of the chapter, we get into some inequality stuff, which is actually easier than the first half of the chapter. So I guess I don't really have anything else to say about that. Okay, so let me first of all show you a definition of a system of equations. A system of equations sounds really fancy. Is a set of equations, two or more, with the same variables. Okay, now I'm going to show you an example of one that is, and then we're going to talk about a one that's not. So just so that you understand this definition. A set of, oh, yep. That's a 2. You critic.
Elijah is not good to judge.
Owen is correcting my grammar. Was that you?
I was Elijah.
No, on the test?
No. That was
Owen didn't like that data was plural? Yeah, I do.
It's supposed to be I, not some.
No. It was data. Data is a plural also.
I was just my kid.
I was like, who's correcting that? It was you. Okay, so a system of equations is a set of equations with the same variables. Now, back in the old days, when I did this in high school, here's an example. There's an example of a system of equations. Okay, so I want to explain that. We're not going to do anything with this one. I'll let you write it down. Okay, so you can see there's a set of equations. And so anyway, what I was saying, when I was in high school, they would always put those little wiggly brackets there. Don't worry if you can't make it, just make a squiggle. But they don't do it now. I don't see it in your textbook, and I don't see it on the SAT or the PSAT. They just expect you to know. They'll say, this is a system of equations. I will pretty much always put those little brackets because that's the way I learned it, and also because then you know they go together. Now, you can see that there are 2 equations, and they have the same variables. They each have x's and y's. That's what all that means, is it's 2 or more equations with the same variables. You do not have to worry about the or more parts. We will only be doing 2 equations with 2 variables. We get into the more than that in algebra 2. Okay, so don't worry about it. Okay, let me show you what's not. You don't even need to write this unless you feel like you want to. But this is a non-example here. Okay, so if I did something like this, 2x plus 5y equals 13, and z plus w is 10. Okay, no, you don't have to. Why is that not a system of equations based on my definition? Elijah, what do you think?
Because there's an X and a Y.
Yeah, the bottom one doesn't have an X or a Y. So when it says it's two or more equations with the same variables, that bottom one has z and w. It's not x and y. This is not a system of equations. That's why. Okay, how about this? Why is that not a system of equations? Yeah, there's only one equation. Okay, so those are the things that have to be true for it to be a system of equations. Oh my word. Okay, so there are 3 ways to solve a system of equations. 3 ways. I don't know why I put a dot. 3 ways to solve. And honestly, you guys, a system of equations. Most of the time, we don't even say system of equations. It's too much to write. We just call them systems. 3 ways to solve systems. Okay, so first of all, we got to know what it means to talk about solving. When we're solving, we are finding the x and y that make both equations true. We'll do an example of that in a second. Okay, so there are 3 ways I'm going to teach you how to do it. There's actually a lot more than 3 ways, but these are the ones we're using. So a pretty standard 3 ways to solve.
No, she didn't. 3 ways.
Okay, so 3 ways to solve the system of equations. First one is by graphing. This one is what we're going to spend our first day on. We're talking about graphing. Number 2 is by substitution. And number 3 is called elimination. Okay, 3 ways to solve systems of equations. Okay, graphing, substitution, elimination. Okay, now that's pretty much the heavy writing part of this. So as far as words, we're going to talk about, first of all, we're going to talk about, is it a solution? Okay, so a solution, one more time, is the x and y that make both equations true. So let's say we have this right here. So let's say I have 2x plus 2y equals 14, and x plus y is equal to 7. Okay, so this what it'll look like in your book is 4, 3, a solution. These are yes/no questions, but you got to have some work behind it. It's not hard work either. That's the nice thing about these questions. This is easy work, light work, as y'all say. This is light work. So, well, I got people still writing, just a second. Okay, so this is a coordinate point. So we know that 4 is what? X or Y? X. This is X. What is 3? So literally all we're going to do is come over here and say with this top one, 2, what does x think it might be? 4. Plus, there's a 2, and then y is 3. And we want to know, question mark, does that equal 14? Okay, because listen, let's order of operations this. What's 2 times 4? This is 8. What's 2 times 3? Is 8 plus 6 equal to 14? Okay, this is correct, but it has to be both equations true. This one's easy because I made it easy for us. Okay, what is x? 4. What is y? 3. Does 4 plus 3 equal 7? Yep. 4 plus 3 is 7. So the answer to the question is yes. That 4, 3 is a solution because it made both of those equations true statements. That is what it means for something to be a solution. Okay, so let's try another one. So let's say we have y equals 5x plus 1 and 3x minus y equals negative 5. So let's go 3x plus y equals negative 5. Is 211 a solution? Could you say that again? Yes. Okay, remember what we were doing squiggly lines with, but yeah, they're the same squiggly lines. Domain and range, maybe.
It's like where you plug, it's like where you're trying to figure out that like number that you use. Like it was like this number x is larger than less than 4. Like that. The chapter that we did before.
Domain and range. Yep. Okay, so this x, this is y. So come up here. Guys, this is just like a recipe or a formula where you're plugging the things in. What is y? 11. Okay. And then it says equals 5 times, what is x? 2 plus 1, because that's what it says. Plug in x, plug in y. Is that a true statement? Yes. This is 10 plus 1. That's correct. That's 11. Okay, now let's do this one. Okay. 3, what's x? 2 plus y was what? 11 equals negative 5. True or not true? No, this is 6 plus 11. That's 17, and that's not negative 5. So is this a solution? No, because it has to make both of those pieces true. Okay, it has to make both pieces true. So I'm going to give you one. I want you to try. And once you've figured it out, I want you to consult with the person sitting next to you. Please do not steal their learning moment, though. So you try it and then compare with the person sitting next to you. Don't steal anybody's learning moment because everybody's going to have to do this on a test. And let's go. Okay, so, and I got to give you the point. Is 2, negative 1 a solution? Okay, so please try that. And if you're not sure what you're doing, this is your good time to ask. Make sure that you are asking what's going on. What's it say here? So your minus that. So this minus that, right? So what's that? Now you want this multiply. Multiply and then go from there. If you feel like that's not working, pop it in your calculator exactly the way it was. So, all this is plugging some things in, okay? So this is your x, this is your y. Oh, I see. Okay, so, you're gonna write it down, so you're gonna replace each of these x's and y's here and see, is it actually, does that make sense? In for x and y.
So it's gonna be 5 times 2.
Minus 2 times
Oh,
And then I see if it equals.
You see if it equals what?
Oh, could I just put it in my screen calculator?
Yup.
I got it is a solution. I got you guys.
Well, I meant to.
This is, minus here, right? You get it minus.
It is a solution. Oh. Yeah.
I did not.
I thought you said is. I thought you said is. I thought you said the answer is.
Maybe it is.
Oh, good, good choice there. Okay, so here's my question. Does the point 2, -1, does that make the first equation true?
Yeah.
Yes, it does. Because, gotta watch your negatives, right? So, this is 5 times 2 minus 2 times -1 equals 12. This is 10. This is positive 2. So 10 plus 2 is 12. How about this? Does it work in the second one? I think it does. Okay, so this is 4 plus a -1. So this is 8 minus 1. That's 7. So yes, this is a solution. Do we have any questions on this? Yeah, it's a nice cursive E, yes. Okay, I want you to give me a thumb, like anywhere from bottom to top. How do you feel like this makes sense or does not make sense? Okay, we'll move on then. So, the goal of solving a system of equations is figuring out, like, this is a question, like, is this a solution? Also, you'll see that on the PSAT, okay, because that happens. You just plug them in just like that. But the goal of solving a system is for you to come up with the actual answer, okay? So, we're going to talk about solving by graphing. We will spend today and tomorrow on that, and then we'll be done with it, okay? So, solving by graphing. Do you have any questions, Grayson?
Yeah, I got it.
He's just venting.
Oh, just venting? Sign out for me for Mr. Smith's room, please. Oh, crap. Okay, so when we solve by graphing, the way that we do it is we literally graph those two equations on the same x and y axis. Okay, so this is how you solve by graphing. Okay, so you're going to graph both together. Go ahead. I'll just approve it. I'll put in. Go ahead. Okay, so write that down. And then draw yourself a nice XY axis. Because we're going to graph. You just really want to come back this way?
I do.
Yeah. Are you sure? No, it's back and back. Oh, back by where you're sitting. I'm thinking that's yours, that large knot of fleece. Okay, so here we go. Okay, so this guy right up here. Y equals 2x plus 1. And this, my friends, is why we did what we did on our warm-up. It's got to remember how to graph things. For the first one, what's his y-intercept? 1. And the slope tells us to do what? Up 2 over 1, right? Remember that this is a 2 over 1. So up 2, right 1. Okay, and then draw your line. Okay, let's talk about the second line. What's his y-intercept? 6. So that's this up here. What does the slope tell us to do? Down 3, right 1. Down 3, right 1. Puts me here. Okay, there's our lines. So my question is, once they're graphed, if we're solving it, what do you think we're looking for? Where they cross, correct. You're looking for where they cross. So that's called the intersection point. Okay, so where they cross is called the intersection point. If you take driver's training, intersection is where roads come together, right? So this is an intersection point because it's a point where they cross, where they come together. What is that coordinate point where they touch? 1, 3. Remember X first. So 1, 3. So that is the answer. So this has one solution. Okay, and we're done. You can check it just like we did if you want. If I do 2 times 1, that's 2, plus 1, that's 3, so that's correct. If I do 6 minus 3 times 1, that's 6 minus 3, and that equals 3. So that's correct. We know we're correct. Now, I want to show you a couple things. These are SAT questions. Okay, now, I want you to understand we're not doing these, but I want you to know that you could solve some advanced math questions on the SAT. Hang on, I got to cover up the answer. Okay, so here's a graph. Okay, it says this is a graph of a linear equation and a nonlinear. We talked about nonlinear in chapter 3, I think, which was first semester. But that curvy line is nonlinear. That's all it means. Don't worry about it. There's the system of equations. What's the solution to that one? It's 4, 5, because that's where they cross. You guys, that's a SAT question. That's in the advanced math section, and you can absolutely do it. So don't freak out when you see SAT questions. Be like, oh, I know what the solution is. It's where they cross. So it's 4, 5. Let me show you another one. Okay, this one I want you to, just a second, we're going to go like this. 1, 2, 3, 4. Okay, I want you to hold up, once you figure out what the solution is, A, B, C, or D, I want you to hold up 1, 2, 3, or 4 fingers. Once you figure out what the solution is, show me with your fingers what you got. Keenan, you with me today? Renee? 10, 3 is correct because look where they cross. It tells you this is absolute value. Who cares? Just look at it. What do they want? What is the solution to the system? Here it is. It's 1, 5, which is number 3. Okay? Super easy. Okay, look at this one. Also, this happens in the easy category. Okay, we're going to go the same deal. 1, 2, 3, or 4. Okay, 1, 2, 3, or 4. Oh, sorry, you got to see them. There you go. Here's your other line. If it's hard for me to find it, it's horizontal down there. Okay, so I got a couple different ones here. I saw a 1 and a 3, but it's 4. Because look, they even put the dot on there for you. You don't even have to guess. This is 4, 1. Not -1. -1 would be below the axis down here. Okay, it's not 0, 0, 0, 0 would be here. There's not even graph there. Like, where do they cross? They cross at 4, -1. Okay, now let me give you a little bit different here. Okay. This one you can, we'll go 1, 2, 3, and 4. So this is, I'm going to zoom in for you, if I can, a little bit. Okay, a little bit different. So look at what the question says. The question says, how many solutions does this system have? I know it's hard because you're going to be like, the number that you may be thinking is not the same as the number of the multiple choice. Okay, so how many solutions does this thing have? Okay, so okay, so tell me in numbers, how many, don't tell me the ABCD number, tell me how many solutions does this have? 2. Right, because there's 2 places it crosses. You guys, this is not just advanced math, that's medium difficulty. You get more points for that. Okay, sweet, because look at, now let me teach you one other quick thing about SAT stuff. This is blah, blah, blah. Always read the question first. It's really weird. It's really weird. And when I say the question, I'm not talking about this stuff. I mean the actual sentence that's a question that ends with a question mark. Because if you look at this, how many solutions does this system have? You can answer that question without knowing any of those things. Okay? There's just a lot of blah, blah, blah in there. Okay, last one. We'll go back to our 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, again, I want you to see it's only the question that you need, and that's true 90% of the time. What is the solution to the system? You don't care what it is, if it's 2 lines, if it's 2 curves, you don't care. Just want to know what's the solution. Marina, what do you think? Oh, just check. You're playing the fingers. So it is C, because those cross at the point 2, 4. Okay, so tomorrow we will talk about what is the problem with solving by graphing, and then how do we make it so you're always going to get the right answer. Okay, so you may put your phone away, you may grab your calculator, whatever. You know, I'm tired.
What's going on?
What's going on, Elijah?
What's going on?
After class.